And today's learning target is brought to you by Scooter the Bulldog. So I'm giving you area, and you are giving me side length. Now, there's two different ways you can go about figuring out a problem like this. I have a square. I know its area is 25 square inches. First thing I can do is just guess and check. I'm just going to guess a number that when I multiply it times itself, I get 25. So, I don't know, I could guess like, I don't know, maybe it's 4. Maybe it's 4. Let's do 4 times 4 and just check. I want to make sure I get 25. 4 times 4 is 16. Okay, that's not going to work. I know it has to be a little bit bigger then. Let's try 5. What if the side length is 5? What do we have there? 5 times 5 is 25. Boom! That worked. Sometimes you have to guess and check a lot. Sometimes you have to guess and check a very little bit. But in any case, the side is 5. All right. Okay, now we'll look down here at the square root of 25. Now, something else I should tell you is that technically there is 2 different square roots. The first, well, we already know the square root of 25, by the way. This little radical sign means I want the square root, or the 2 numbers that multiply by itself to give you 25. Anyways, we just did that up here with this square. The answer is 5. But technically, negative 5 times negative 5 is positive 25, because a negative times a negative is positive. Anyway, technically there are 2 square roots. Sometimes we just write that positive and negative 5. All right? Now, the other way that you can find square roots is it can be super helpful if you just make yourself a list of perfect squares. So here's a list that I have. And something I can do is I'm just going to go down my area column, and I'm going to look for the area of 25 here. Oh, there it is. So then I know its side length is 5. So there's another trick. It can be helpful to have one of these. Makes your guessing and checking work a lot faster, okay? So there is your 2 ways. All right, so what you should do now is you should pause, and you should try to do these 2 on your own. Go ahead and pause and give these 2 a shot. All right, after pausing, you should get positive and negative 9 is your solution here. And then over here, when you have a fraction, the best thing to do is, well, there's 2 different things you might want to do. The first is sometimes simplifying the fraction can give you a perfect square, okay? Or possibly the numerator and the denominator are already perfect squares. And if I look at my list of squares here, my list of perfect squares, I have 36. That is 6. I also have 100. That is 10. So my square root here, if I treat the numerator and denominator separately, I get 6/10, which I can reduce to 3/5. And I have to make sure I want the positive and the negative square root, because there's both. All right, now, if you have a square root that's mixed in some larger expression, then I only want to think about the positive square root, okay? So you really have to pay attention to the instructions on whether or not you want the positive, the negative, or both square roots. Kind of depends on the instructions. So anyway, looking down here, I only want the positive square root. And off to the side, I'm going to write this down here. I'm going to remind myself of this thing. PEMDAS. And we are going to put a little star next to the E for exponent. Put a little star there. And that's because when you are solving expressions, the square root sign, that's really like an exponent. You want to do it in the same order that you would have done for exponents. So I don't see any parentheses, but I do see an exponent hidden in the square root. that's the first thing I want to do when I'm simplifying or evaluating this expression. So instead of 5 times 36, I know this is really 5 times 6. The square root of 36 is 6. And I'm going to keep simplifying. I got multiplication, but I also have addition. I want to make sure to do the multiplication first. So this is 5 times 6 is 30. And 30 plus 7 is 37, and there is my answer. Hey, go ahead and pause if you would like to, and see if you can evaluate the next two expressions on your own. Okay. If you've given this a try here, the first thing I want to do is evaluate this square root here. And it turns out that 18 and 2, if I try to find the square roots of these numbers, well, I'm going to get some crazy obnoxious decimal known as an irrational number. And if I look at my list of perfect squares, you'll notice that 18 is not on here. There is no, it's not a perfect square, we say. It's somewhere between 4 and 5, but it's an irrational number. Same with 2. If I look for the square root of 2, it's not here. It goes from 1 to 4. It's not a perfect square, we say. It's some crazy decimal. Anyway, that's not going to work. But what is a perfect square is 18 over 2. That reduces to the fraction 9. You can simplify that fraction. This is just 1/4 plus the square root of 9. 9 is a perfect square. The square root of 9 is 3. Square root of 9 is 3. So we got 1/4 plus 3, which is just 3.25, or 3 1/4, 3 1/4. All right. And then this last one here is kind of funny. I'm going to do what's in the parentheses first. So in parentheses, we have the square root of 81. Well, if I go to my list of perfect squares, the square root of 81 is 9. So this becomes 9 square minus 5 equals, and 9 square, 9 times itself, is 81. 81 minus 5. 81 minus 5 is 76, which is my final answer here. Okay. Now you might have noticed, well, what the heck? We started with 81 in the first place, and yeah, that's true. And that's because squares and square roots, they cancel each other out, actually. All right, so you could show me these steps, or just cancel out the square and the square root. Okay, moving right along here. All right, sometimes you have these equations now with x squared in them, and here's the fun little diagram I'm going to give you when you have to undo a square in some kind of equation. So up in the corner, I'm going to have you draw this little picture here. Let's go ahead and write side. And let's go ahead and draw a little arrow like this. We got x squared. And then let's draw a little thingamabobber like that. Let's put area. And let's do a little thing like that. And then we get to the square root of x squared. And basically the way this works is if you start with the side of a square and then you square the side length, that brings you to area. Then if you're to take the square root of the area, that's going to take you right back to the side length. Basically, squaring and square rooting, these are inverse operations, they undo each other, which is super helpful if you have an equation with x squared. For example, this one here. To undo the square, you're going to have to take the square root of both sides. X squared equals some number. I want to get rid of the square. We're going to take the square root of both sides. Take the square root, take the square root. The square and the square root cancel, leaving me with just x equals the square root of 9/16. Well, these are both perfect squares. The square root of 9 is 3. The square root of 16 is 4. So that becomes 3/4. Okay? Moving right along here, same thing. I want to get x by itself. That's the goal. Now, before I can get rid of the square root, I do want to undo this multiplication first. So let's divide both sides by 2. This is going to leave me with x squared equals 49 after I divide by 2. Now I want to get rid of this square. We're going to take the square root of both sides. The square and the square root cancel out. It leaves me with x. The square root of 49 is, well, I can guess and check, or I can go to my list of perfect squares. I'm looking for 49. Is it a perfect square? Oh, it is. 7. So then I get x is equal to 7. Cool. And last but not least, we do come across these kinds of equations. We want to get the x by itself. We're going to have to get rid of the pi. Divide both sides by pi. Pi's all cancel. Leaves me with 9 equals x squared. Take the square root of both sides. And 3 is equal to x, or x is equal to 3. Okay,